We'll just so hi eighth hour. Who wants to say hi to eighth hour? Okay, Larry will. All right. So go ahead, Lindsay. You can say hi first to eighth hour.
Hi.
Is there anybody special in eighth hour you want to say hi to?
Sarah.
Sarah who? Sarah Sanderson? Tara. Tara Westland. Oh, hi, Tara. Lindsay says hi. I bet that makes Tara feel great. All right, Larry, your mic's hot. It's on. It's ready to go. So who are you going to say hi to?
No one. I hate them all.
Whoa! Larry hates y'all. All right. Well, to each their own. Guess we know how he feels. So, okay. All right. Well, you're going to need your graphing calculators as well. Take out your graphing calculator. And what I want you to do is I want you to turn to your very back sheet. Okay. So again, please bear with me. I have not looked at these notes at all. Okay, I'm going completely blind into this, so we'll just do it by investigation. I think we'll be good to go. So it says we want to graph exponential and logarithmic functions, and you guys are used to graphing stuff that looks like this. Y equals x squared. That's easy, right? Well, what about this? What if I go y equals 2 to the x? That's a power function. That's an exponential function. See the difference? That totally changes the shape of the function. So that's what we need to be able to look at. This back sheet here is a sheet of notes for you to always refer to, along with the notes that you have for the rest of the unit. We want to graph y equals a to the x for values a greater than 1. So let's go to our calculator. We'll get an idea what those look like. Y equals. All right, so somebody give me a number. What do you want to put in? 7. Okay, we got 7 to the x. Let's do 2 more. What else do you want to do? All right, we'll go 2 to the x. We got to be greater than 1. Let's go 1.2 to the x. Let's graph all 3 of those and see what happens. Okay, so what do you? Somebody tell me something interesting. They go up. Okay, the bigger number, the steeper the slope would be at any given point. They all they all cross the y-axis at the same spot. They don't ever touch the x-axis. What do they cross the y-axis at? 1. So let's make sure we put that. That's a very important thing. So we're going to put a dot there at 1, and the graphs look like they go like this, and they head up through there. So that would be a general shape. Now, why does it cross through 1? What is the x value at this coordinate? 0. So that'll be y equals some number a to the 0 power. What is anything to the 0 power? 1. So that's why it goes through 0, 1. Does that make sense? Now, my good friend Erin brought up a very good point. She said, let's put in -3. I want you to think about this. If we had y equals -3 to the x, let's type it into our calculator and see what happens. We're going to clear these out. Yep. Let's try looking at the table values and see what's going on. Get all sorts of errors and different values. It's interesting. We don't plug in negative values for x. I'm sorry, we don't plug in negative values for the a. Okay. Zero for a. Yeah, you try it. What are your guys' stuff coming up with? Okay. The problem is your calculator doesn't know what to do with the negative. Think about it. If you have -4, what's -4 to the first power? -4, right? What's -4 to the second power? 16. What is -4 to the 1.5 power? All of a sudden, that's, yeah, you could do 3/2, right? And you could possibly come up with an imaginary result. So think about trying to do to the 9/4 power or to the square root of 2 power. All of a sudden, how do you actually evaluate that, especially if it's not a rational number? So that it's difficult. Your calculator really doesn't know how to go through that process, and we don't really talk about it. You might want a better explanation. You're not going to get one until we deal with logarithmic functions. So let's deal with the second part that we want to look at, which is, let's suppose that a was between 0 and 1. Let's go to our calculator, and let's go to y equals, and now we're going to type in where a is between 0 and 1. What would you like to choose? All right, so we've got 0.5 to the x. Yep, thank you. 0.5 to the x. What else would you like? All right, we'll do parentheses 1 divided by 3 to the x. Yes. And then, oh, you don't have to parentheses on the 0.5. And let's go 0.9 to the x. If I graph those, how are they similar? How are they different? Yeah, they still cross at 1 on the y-axis. They have that general shape. And what you can really do is this. Here's what I want you guys to understand is this. Let's suppose that you had y equals 1/2 to the x. Is that not the same as this? Y equals 2 to the negative x. What I did is I transferred that negative exponent and took the reciprocal of that. Remember, when we have a negative in our exponent, we flip the base? So that's what really happened. And you remember before when we talked about transforming functions that if you had a negative on the x, it flips it over the y-axis. It's a horizontal flip. Look at what you have. Okay, so that's why these are horizontal reflections of one another. And that's why you get what you get. E is this very special number. E is a number that comes up in growth in natural situations, growth of money, growth of bacteria, growth of all sorts of stuff. E is a number like pi, 3.14, except E is 2.718. And if we take e to the x power, which one is it going to look like? The first one or the second one? The first one. Okay, again, we'll cross through that one spot. And y equals e to the negative x is the same as y equals 1 over e to the x. So that's going to look like the second one. You need to be used to using e. E is just a base. E is a certain value for a that we plug in. And you'll learn how to apply that number and use it quite often. Okay, let's go to the front part to our examples. Okay, it says sketch a graph of the following functions. And what I would encourage you to do is just simply get 2 points on that function, okay? So y equals 4 to the x. What's 1 point you know is going to be on that function? 0, 1. Let's try to get another point on that function. If I plug in 1, 4 to the 1 power is equal to 4. So the coordinate 1, 4 is on that function as well. So you could go over 1 and up 2, 3, 4. So, and you know what flattens out back here? So that's what my graph looks like. How about y equals 1/4 x? What's the coordinate on that? 0, 1. If I plug in 1 for x, I get 1 over 4 to the 1 power is equal to 1/4. So I have the coordinate 1, 1/4. So I'm going to plot that. Over 1 and up 1/4. And you can get the exact feel of the type of shape this is going to have. Now, looking at it ahead of time, recognizing that the base is greater than 1, you should know that you're going to have that type of shape. Recognizing that the base is less than 1, but greater than 0, you should have that shape. But this will at least help you get, some points on there. All right, next one. Coordinate at 0, 1. And I'm going to have another coordinate at 2 to the first power is equal to 2. So 1, 2 is another coordinate. So you can see that that doesn't have quite as steep of a slope as the very first one. Got the idea? Let's try some that are just slightly more difficult. Yep, always passes through 0, 1. Okay, now I have y equals negative 8 to the x. What's different about that? It's negative. What does a negative on the outside of the function do? Flips it over the x-axis. It is a vertical reflection. So I'm going to draw the original one in black. The original one is going to look something like that. Would you agree? So I'll draw our new one in red. So instead of passing through 0, 1, it's going to pass through 0, negative 1. And again, you can always check this on your calculator to make sure that you did it correctly. Y equals 3 to the x minus 4. I'm going to draw my original one. It's going to pass right through 0, 1. Tell me, what is the minus 4 going to do to it? Everything is going to be shifted down 4. So instead of passing through 0, 1, it's going to pass through 0, 0, negative 3. Now, let's hold on there. What line, this is very important, you guys, what line does this graph approach? Approach is x equals 0, right? Look, it never touches this line. And if it never touches that line, we call it an asymptote. Remember that word? We don't touch it. We approach it, but we don't touch it. So that asymptote, instead of being at 0, is going to be at -4. It's going to be shifted down 4 units. Again, we're shifting everything down 4 units. So instead of the graph passing through 0, 1, pass through 0, -3, because it's shifted down 4. Similarly, you have this asymptote. Instead of it being 0, we subtract 4, we get -4. So it's going to approach but not touch that line. That's a very important part of your graph. What do you think about that? We could. I just did that to help you kind of see that if you want to make sure, you know, whether it goes up or down, that you could just plug in a point. So let's do that, though. Let's plug in 1. So if you plug in 0, what do we get? 3 to the 0 is 1 minus 4 is -3. So you can see we pass through 0, -3. Now, if you want to find another point, if you plug in 1, what's 3 to the 1? 3 minus 4 is -1. So 1, -1 would be another point on that. I just plugged in 1. 3 to the 1 is 3. Minus 4 is -1. Plug in 2. 3 squared is 9. Minus 4 is 5. So my point is that if you ever want to try to generate the shape by plugging in points, you sure can do that. All right, let's try this. Let's try f. Y equals 2 over 3 to the x minus 2 plus 1. What is the original shape going to look like? It's going to go the opposite way, right? Because it's 2/3. These graphs don't have to be exact. We just need to kind of shift them and understand how they're shifted. Tell me, what does the x minus 2 do to it? Shift to the right 2 units. So instead of passing through 0, 1, that point will be shifted right 2 units. And so it will pass through what? 2, 1. So my new one will pass through 2, 1. But then it's shifted up 1. So if it's shifted up 1, then it'll pass through 2, 2. Exactly. If it is shifted up 1 unit, what is the new line for the asymptote? The new line for the asymptote will be y equals 1. So everything shifted up 1 unit, so this is going to pass right through there. And that would be sufficient to draw a graph like that. If you want more points, just plug them in. You'll be able to generate. If you want to check on your calculator, you can go ahead and type stuff in. Any questions on the graphs? If you look at these 6. Okay, please flip it over to the back side. All right, it says find the exponential function that passes through the following points. So all of these pass through what point? 0, 1. So we know that we're going to have this. Y equals a to some number x. So what I'm going to do is I need to find a. I'm going to use a point in order to determine that. I will use 225. 25 is my y value, equals some number a to the second power. What number would a be? 5. So a must be 5. So therefore, my function is y equals 5 to the x. Can it be negative? In these examples, I don't believe they come out negative. Oh, because you're saying if you square a negative 5, you also get positive 25. Right. I understand. No. Remember when we started out from the beginning, we said that a was going to be either greater than 1 or between 0 and positive 1. We said when we plugged in that negative value for a that caused us issues. We'll talk more about why that is when we get to logarithmic functions, but for right now, we'll always keep a positive. Okay, good question. All right, we go back to the spot. So same situation here. I need to find a. I know I'm going to have y equals a to the x. My y value is what? 2/3. What number do you take to the negative 1 power in order to get 2/3? 3/2. Taking something to the negative 1 is like taking the reciprocal of it. So a is going to be 3/2. Now there's two answers for this. You can either write it like y equals 3/2 to the x power, or you could write it y equals 2/3 to the negative x power. You guys see that those are the same? So technically you could write it either way. Either one we plug into our calculator will give us the same result. Two more. 0, 1, and 3, 8. We need to find a. Y equals a to the x. So we have 8 equals a to the third power. What number do you take to the third power to get 8? 2. So a is 2. So therefore my function is y equals 2 to the x. And somebody give me another way to write that function if I so wanted to. Right. Y equals 1 over 2 to the negative x would be the same thing. You don't have to write that, but I just want you to realize that. Either way would be correct. I would give you that credit. Okay. And then we have this one right here. Again, I need to find a. And I have y equals some number a to the x power. My y value is 1 over 10,000 is equal to some number a to the 4th power. What do you take to the 4th power in order to get 1 over 10,000? 1/10, yeah. So you could write this as y equals 1 over 10 to the x power. What's another way you could write it? Either way is fine. So this is a basic introduction to exponentials. Do you use exponentials in calculus? Yes, primarily in calculus 2. So it is something that we do get to. We should be good at referencing them. Exponentials are very important for working with the next section, which is logarithms. The good news is this. As I check with your teacher that you had last year, she says that basically you guys covered just about all this stuff. We're just going to do it faster, and we're just going to extend into some word problems. That's the only difference. So we should be referring to material that is somewhat familiar to you. I'll pause this video, and I will put up your assignment. Okay. Okay, that's it. That's your assignment. Do your best to sketch your graphs without using graph paper. If you need graph paper, I don't have any on hand, and I'm not going to have time to copy some. I will say that there's a very good chance that you have a homework quiz before Christmas break to make sure that you're keeping up with the work that you had. Now, obviously, that could very well change if we do not have school tomorrow, or depending on what my schedule is like. But if I'm here tomorrow and if I'm here tomorrow, you got an assignment, I'd say make sure you got your assignments done for today and tomorrow. So try to keep up, because the worst thing that could happen is we need to commit this material to long-term memory. Right now it's in your short term. The only way it gets it to your long term is for two things to happen. A, for you to practice it, and B, for you to sleep. So if you don't do those two things, you won't be able to do it in the future very well at all. Okay, so make sure you do that. Use your time wisely.